Welcome back, guys. Again, question number 2, and today we are going to solve part C of it. Recently we have covered all the basic steps when the impedance was solely consist of this resistive element, and in part B the impedance was basically the inductive reactance. Today in part C we have the capacitive reactance, which has the value of 100 ohm, and the voltage which has been developed across it is basically 25 sine of omega t minus 20 degrees. Okay, so let me start it, and let me go down, and here in this part C the value of x of C is 100 ohm and the value of voltage is 25 sine of omega t minus 20 degrees. Okay, so what we have to find out, we have to find out the value of current, and then we have to plot the voltage and current over the same axis. Okay, so let me proceed in it, and here in order to proceed it, what is the procedure here? So again the formula which we will have will be I is equal to V by Z, where the value of Z is unknown. So here the value of Z is also 1 over j x of C, because x of C is known, and it will be like this one. So here it would be minus j over x of C, because j is equal to, because here I can write that j multiplied by j is equal to minus 1, and therefore j is equal to minus 1 over j. Okay, or I can also write that minus 1 over j, for minus 1 over j, minus j is equal to the 1 over j. Okay, so by using this rule here I have used it, and here minus j over x of C, so that is 100, and here it would be minus j 0.01, and in rectangular form it would be 0 minus j 0.01. Okay, and in polar form it would be, the amplitude will be 0.01 and the angle with it will be, because this is the minus j, so here it would be minus 90 degrees ohm. Okay, so that is the impedance here. What is the value of V? So in order to calculate the value of V, we have this peak value. So in order to convert it into the RMS value, I have to divide it over this square root of 2, and writing the angle here which is minus 20 degree here, and that is here as well. Okay, so 25 divided by square root of 2 is equal to 25 divided by square root of 2, and that is the 17.67. Okay, so 17.67 or 68, and the angle with it is minus 20 degrees, and this is in volts. Okay, so now using this equation which is I is equal to V by Z, so putting all the values here, so I is equal to the V by Z's value of V is 17.68, and the angle is minus 20 degrees, while dividing it over this 0.01, and the angle with it is minus 90 degrees. Okay, so now again simplifying it, so 17.68 divided by 0.01. Okay, so that is 1767.8, 1767.8, and the angle here would be minus 20 degrees plus 90 degrees. So ultimately I will get this I, and that is 1767.8, and the angle with it is basically 70 degrees. Okay, so that is in ampere, and that is the answer in polar form. In order to convert it into the sinusoidal form, what I have to do, I have to use the same formula which is sine of omega t, and with it the angle would be 70 degrees, okay, but the values here will be 1767.8 multiplied by square root of 2, okay. So, multiplying it with the square root of 2 would be, that is 2500, okay. So, that is the expression for current, okay. So, now in order to plot it, what I have to do, the same procedure again. Let me move down here, okay, and here again defining the axis. This is the axis here, this is time, okay. So, let me first write the value of current here. So, the value of current here, let me write it with this blue, and that would be 70 degrees away. So, with 70 degrees away, let me write somewhere here, okay. So, it will be like, okay, and it will be like this one. This is just like 70, and here the amplitude, what will be the value of this amplitude? This is 2500 and this is minus 2500, okay. Similarly, now in order to write the value of minus 20 degrees for the voltage, and for plotting the voltage, what I have to do, I have to use this minus 20 degrees, and minus 20 degrees is basically 360 minus 20 is 340. So, it will be somewhat here, okay. Let me use this one. So, it will be somewhat here, yes, and the amplitude here is somehow very low, and that is 25. So, writing it like, okay, just like this one. So, here the amplitude will be 25, and here it would be, here it would be minus 25, okay. So, this is for the voltage, while this one is for the current, and you can very easily see that the positive voltage is attained by the current earlier than that of the voltage. So, therefore, in the capacitor, current leads due to the x of c, while V lags, okay. So, that is because of the attainment of the positive value, the current value in the waveform, okay. Similarly, if you want to see the difference or the phase difference between the voltage and the current, you have to write this 70 of the current and then writing minus 20 here. You will see that there will be the phase difference of 90 degrees between the current and voltage in the capacitive circuits as well. But what is the difference between the inductive circuits or the inductive reactances and the capacitive reactances when voltage and current flows? In inductive circuits, voltage leads by 90 degrees from the current, while in the capacitive circuits or in the capacitive reactances, the current leads the voltage 90 degrees, okay. So, that is all about our question, in which we have so far discussed 3 parts of our question. So, in order to clarify the conceptual overview of these type of circuits, it was indispensable for me to solve them separately. So, I think the concept is now clear, and I will see you with some other questions in our upcoming video. Thank you so much, and I will see you soon.